Okay, so we've got unusual glass that we produced this year. So normally composition J is a cobalt glass, and so it has about 0.05% cobalt on just a normal soda lime glass. You get a nice blue color, and with chromium you get a green color. It's a little hard to see, but you can kind of see that nice green color there. So this year we tried adding an opacifier, Zircopax, which is about a 60-40 mix of zirconium oxide and silicon dioxide. And so it's supposed to be an opacifier, but as the carbon dioxide was bubbling off of the flux, you add sodium carbonate, calcium carbonate, it converts to sodium oxide, calcium oxide by throwing carbon dioxide. You can see we formed a stable glass foam, and I have this glass souffle here. So apparently the presence of that Zircopax has stabilized those bubbles, made them persistent. So there's the recipe. See, 89 grams of silica, 63 grams of potassium. In this case, we actually used sodium carbonate, not potassium carbonate. Then calcium carbonate and the Zircopax. Actually, that's making me wonder now. I intended for that to be sodium carbonate, but the recipe here is stated as potassium carbonate. Yellow flag on the play. That could actually be what's going on here, is that it's a combination of the zirconium as well as the potassium flux that increased the viscosity. I bet you that's what happened. So we have this interesting glass foam, and so my guess is this, my students actually did follow that recipe as written: potassium carbonate, calcium carbonate, Zircopax, 10 grams, and then chromium and cobalt oxide. So we want to kind of bust into these and see what kind of glass foam we actually produced internally. So we're going to start with the let's start with the chromium. So we'll just sort of dig in here and see what kind of trouble we get into. So it's kind of like glass styrofoam, actually. This big bubble right there. It's a lovely sound. It's like lava. Kind of weird, swoopy curved bit there. So we're working our way down through. Actually applying a fair amount of force there. Might be hammer and chisel time. So I get further down in, the foam gets much more dense, and presumably the bubbles get a whole lot smaller. So I can see that's cracking down there, but let's see what I got to get at that. Don't really have a traditional flat chisel, so I'm just going to try breaking it up with a rat tail chisel and just kind of drill down in. They break off some chunks. Fall it away from the surface of the ceramic crucible. Hopefully not impale myself. It's just drilling right down into that foam, and not really chipping away so much. Really good television. I should be doing it in a way that you can see what I'm doing. So anyway, we got all these little crunch berries here, kind of like corn puff cereal here. Although I would not advise eating this, no matter how delicious it looks. Actually remarkably crush resistant for what it is. Spinning my chisel a little bit, or the tail of my triangular file, not intended for this purpose, of course. These little bits flying off. One of those got in your eye, it would ruin your day. Good that there's not a room full of people here. Alright, this is starting to get a little ridiculous, so I might call it quits. That one. See, we got majority of the goodness out of there. Kind of leaves a foam remaining cell structure on the surface of the crucible. And we've got all this green glass foam inside. So that was the chromium glass, which is composition ZK on the composition sheet. Changing the guards here. In industry, this is called line clearance. Swapping from one material to the other. And my guess is our behavior is going to be pretty much the same for cobalt foam, cobalt line glass foam. We're about to find out. Collection vessel. So beautiful blue foam there. Made a bit of a mess in the furnace, sadly. Looking forward to cleaning that up. But bright blue foam. Let's crack into it. Got a spike on the side of that. I could impale myself pretty well with that. Try to avoid that. It's glass after all. Don't see any blood yet. That's good. Every once in a while it makes this spontaneous Rice Krispie sound, which is kind of unusual. Do a little chiseling here. Kind of want to preserve some of these as large chunks. See kind of where we're at there. That's boom. Nice tourmaline. think I'm pretty much done with this. There's still some in the bottom, but since I don't exactly know what I'm going to do with this yet, the rest of this is probably just going into OCD territory. So you can see the remaining foam and the cell structure and the general size of that cell structure as it laminated against the side. Kind of unusual. Normally, viscosity and behavior of this stuff is such that those bubbles all pop, and it's called fining the glass. Process of removing the bubbles or allowing it to sit long enough for the bubbles to leave. Well, this was not a fine glass. Trapped in that viscous foam. Again, have to verify, but I was thinking this was going to be a soda lime glass, but I think it was a potassium lime glass, and so the viscosity would have been greater, and then evidently the presence of that refractory particle, the zirconia, that doesn't melt out, was sufficient to make this crazy foam. So that is the end of that experiment. So we've got blue and green glass foam there.